So you've found the perfect home. But high mortgage rates have you second-guessing. The Churchill Mortgage team says waiting to buy can be a costly mistake. Try their free 15-minute analysis to see the difference between buying now versus waiting for lower rates. Visit churchillmortgage.com to learn a smarter way to build wealth through home ownership. This is a paid advertisement. NMLS ID 1591. NMLS ConsumerAccess.org. Equal Housing Lender. 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, once again. Thank you for joining us on the Space Nuts podcast. Andrew Dunkley here, and with me as always, my good friend, astronomer at large, Fred Watson. Hello, Fred.
Excuse me. Well,
that's an awesome
a great
start.
Yeah, what a start. I opened my mouth to talk and a cough came out. Sorry about that. I do apologise. It does happen, yes, but I'm still alive. I was actually just practising my impersonation of the Big Bang in case we need it at all, which is very famous.
Fair enough.
No, I'm all right. All good.
That's good to know. I'm glad you're with us.
Yeah, parts of me
now, coming up, this is a really exciting program. Lots to talk about. The UAE Moon Mission. We'll just have a quick chat about that. Matter that appears to be missing in the universe. Has it been stolen? Is it under a mattress somewhere? We are not sure. We're going to go and look for it, though. And a warm Neptune-like exoplanet has been discovered, and we've got a couple of fascinating questions. One, and this we've probably touched on this before. In fact, I know we have, but it's a question that I'm sure crosses many people's minds. With the universe expanding like a balloon out in all directions at the same speed at the same time, how is it then that galaxies can collide if everything's moving away? Good question. And a question about the star system Zeta Reticuli, which is a star system that has been the focus of attention in terms of alien conspiracies. So we're going to address that one as well. Should be a lot of fun and very, very interesting too, Fred. But first, where's the UAE up to with their moon mission? Have they gone into orbit?
Well, they're actually aiming for Mars, Andrew, not the moon.
All right.
Yeah. So,
of course.
So they have
Why
gone
did I
into
think it was the moon?
well, it's all right.
Yeah, okay. Well, they're not near the moon, so don't get your telescopes out.
No.
It's the moon.
It's not.
It's Mars. I've got this moon thing stuck in my head today. Anyway, I'm going to change the word now.
He's crossing it out, ladies and gentlemen, and writing.
It's all officially changed.
It's officially changed, yes, with the Andrew Dunkley ball pen. Yes,
so
it's
the
Mars.
question remains: Have they achieved Martian orbit?
Apparently, they have. Yes, in the small hours of this morning, Sydney time, they slowed. I think they had a 27-minute burn on the main engine of the spacecraft to slow it down, so it didn't just keep on going past Mars and come back to the Earth, which is what would have happened otherwise, or come back to where the Earth would have been if it was that bit of its orbit. So it's slowed down, and we understand it's safely gone into Mars orbit. It's the Hope mission. This, of course, is the first of 3 missions that we're bound to talk about in the next few episodes. The Chinese Tianwen-1 mission arrives tomorrow. Next week, the NASA's Perseverance spacecraft goes through its 7 minutes of terror as it lands on the surface. The other 2 actually both go into orbit. Tianwen-1 will indeed launch a lander, but the main spacecraft will be in orbit. But the good news from the United Arab Emirates and their space agency, and all credit to them, they've successfully achieved what's called Mars orbit insertion. Until they're now in.
Oh, I love it when they do that.
Yes.
I love it when they talk dirty.
Exactly.
I love that.
The tech talk.
Yeah, the tech talk. I really enjoy it. Yes. Okay. And I suppose the one that they're all exciting missions, but Perseverance is the one that I think will probably get the biggest amount of press, at least in our part of the world, because this is much anticipated. This is going to be, the Rolls-Royce of rovers. I think.
It's really interesting, 90% of Perseverance is leftover bits from Curiosity.
Is that true?
Yeah. So it's certainly the Rolls Royce because it's got all kinds of new bells and whistles, but it's basically was it a 2012 model? That's when Curiosity went up there.
Wow.
Yeah.
Well, that's like, what was it? The Skylab. That was just a leftover Saturn 5, wasn't it?
Yeah, that's right. Yeah, and bits of Apollo and bits of Soyuz.
Yeah. Well, we wish them well, and with that, and of course, congratulations to the UAE for achieving their Martian orbital insertion, and maybe one day they will go to the moon.
Maybe
who knows?
They will. Yes, yeah. But just to finish the story, the Hope spacecraft, the UAE's one, doesn't come out of orbit. It basically stays in orbit because its mission is to explore the upper atmosphere of Mars, which I'm sure it will do.
Mm. Yes, which may unlock some answers to questions that have been asked for a long time.
It'll tell us things, that's right.
One hopes. Okay, now, Fred, let's move on to our next story, and that is the story of missing matter. This is basically a story about what do they call it? Normal matter, I think they refer to it as.
Baryonic matter.
Baryonic matter.
Yep.
Which seems not to exist when it should. Is that the story?
It's a really interesting one, Andrew, and we've touched on this issue before because there was some big news last year connected to exactly the same problem. What it's all about is not the dark matter, and that's the first thing we have to say, that dark matter is something that we can't detect except by its gravitational interaction. The only way we know dark matter exists is because galaxies don't fly apart and galaxy clusters don't fly apart. And that tells us there's something there that we can't detect any other way than by gravity. But when you do all the sums, and those sums, by the way, come from observations of, first of all, huge numbers of galaxies to see how they're distributed in the universe, plus the cosmic microwave background radiation, the flash of the Big Bang. All of that tells you that the proportions are very roughly 75% to dark energy. That's the energy that's making the universe expand more rapidly. 20% to dark matter and 5% to normal matter. So normal matter is a tiny fraction. It's actually more like 4% probably of what makes up the universe. And we know we should be able to see it because that's normal matter. It's hydrogen basically, and hydrogen has the property that it's detectable either when it's glowing in stars or nebulae, or when it's cold, which is what we pick up with radio telescopes. But when you add up all that we can see, there isn't enough. And there was a big breakthrough last year, which came from fast radio bursts. As they pass through intergalactic space, they interact with the radiation interacts with the electrons in that space, and it turns out that a lot of that missing matter, the missing normal matter, is locked up between the galaxies because they found a lot with that experiment last year. However, we're still short, apparently. And once again, the radio astronomy world comes to our assistance with a lovely story that actually comes from the University of Sydney here in Australia. Tara Murphy and Wanming Wang, I think is the way her name is pronounced. Two young women astronomers. I know Tara quite well. I've worked with her in the past on giving talks and things. They have produced some really interesting information that comes about in a fascinating way, I think, and it's all about twinkling. We're all used to the idea of stars twinkling as their light passes through the Earth's atmosphere. In fact, twinkling is something that astronomers don't like because it essentially destroys the quality of the images, and that's why big telescopes tend to look high in the sky rather than low down on the horizon, unless you have to, because the lower you get from the horizon, the more atmosphere you're going through and the more the stars twinkle. Now, the atmosphere itself doesn't affect radio observations in that you don't get any twinkling. But if you've got gas at a distance from our solar system and you're looking through that gas, then you might well get the twinkling phenomenon. And it's got a fancy name. It's called scintillation. So scintillation is what you're often looking for in these observations of distant, actually in this case they're looking at distant quasars, which are effectively point sources in the sky, very compact radio sources. They're the nuclei of galaxies that have a supermassive black hole in them that's feeding frantically on its surroundings, and they're extinct today. They're only in the early universe or the earlier universe. So they're using these quasars as back illumination. In other words, they're looking at the light of the quasars to see what happens to it when it gets 99.99% within 0.001% of the end of its journey, if I can put it that way. In other words, when this light or this radio radiation has done its dash, it's gone through billions of years worth of travel, and it gets to our galaxy, where you're talking suddenly about the last 10 years or so of its journey, and it hits a gas cloud, and so you get this twinkling, and it comes about because of the turbulence of gas in the Milky Way. That's what causes twinkling in the atmosphere, twinkling of starlight, turbulence of gas. And in this case, it's the atmospheric gas. But you get the same phenomenon with the light from these distant quasars. And so what they've been able to do, these astronomers they've observed, I think it's a huge number, 30,000 of these distant galaxies they examined, and 6 of them, so it's not a very big percentage, were twinkling strongly, as they say. And that tells you that they're going through a clump of gas. What's really interesting is that this clump of gas seems to be a long string of gas, because the twinkling galaxies, the ones that said, yes, we're going through a clump of gas here, they're in a straight line. They're in a long straight line across the sky, which in itself I think is quite intriguing. And it essentially it tells you that this cloud of gas is probably long and thin. So what they say is, this is from their conversation article, in fact, which means I can quote these scientists directly. The cloud of gas we detected was inside the Milky Way, about 10 light years away from Earth. That means that light from those twinkling galaxies travelled billions of light years towards Earth, only to be disrupted by the cloud during the last 10 years of its journey, which is what I was trying to say far less eloquently a minute ago. So this is the crucial thing, Andrew. By observing the sky positions of not just the 5 twinkling galaxies, but also tens of thousands of non-twinkling ones, we were able to draw a boundary around the gas cloud. And we found it was very straight, the same length as 4 moons, that's 2 degrees, side by side, but only 2 arc minutes in width, and an arc minute is a 60th of a degree. They've said it's so thin, it's the equivalent of looking at a strand of hair held at arm's length. That's not something I often do, as you know, but that's how thin it is.
I'm becoming less capable of that too, I must say.
This is the first time astronomers have been able to calculate the geometry and physical properties of a gas cloud in this way. But where did it come from, and what gave it such an unusual shape? So that then leads them to speculate what the form of this gas cloud is. And they wonder if it's something that they call a hydrogen snow cloud, something that is basically frozen hydrogen. And we've talked about this before, Andrew, because that was one of the theories for what Oumuamua might be, a solid lump of hydrogen that had come from the inside of a giant molecular cloud. So they're saying, perhaps there are snow clouds that make up some of the missing matter of the Milky Way, and maybe that's what these astronomers have detected with their twinkling galaxies. And I should mention, by the way, that this all comes courtesy of the Australian Square Kilometre Array Pathfinder telescope, ASCAP, in Western Australia. That's the instrument that was used to make these observations. It's one that I've visited, as you know. Fantastic piece of technology, 30 or so, I think they're 12-metre dishes, which are scanning the sky constantly. So a nice story for ASCAP as well.
Yes, indeed. Yeah. Is there some suggestion that these gas clouds, these snow clouds, if you like, were created by the oblivion of stars that interacted with black holes or something to that effect? Is that one of the theories?
That's certainly. It's actually one of the things that they mention in their article, that you will get if you've got a star that's being not swallowed up by a black hole, but disrupted by it, because the black hole spaghettifies everything, what you get is the star pulled into a long, thin gas stream. But they've ruled that out as the source of this particular line of gas, if I can put it that way, because there aren't any massive black holes anywhere near that cloud. And, the closest one that they know is 10 times further away than this gas cloud is. It's further away from Earth. I beg your pardon, 100 times further away from the Earth than the gas cloud. It's about 1,000 light years away. So that doesn't seem to be the answer. And that's why they've been led to this theory about the hydrogen snow clouds, which, well, I think is great. We need to probe these ideas, and there will be observations that we can make down the track, and probably the Square Kilometre Array will be part and parcel of that, but they will reveal whether these snow clouds actually exist.
Yes, and if we keep looking, we'll ultimately find all the missing bits of the universe, and then we'll go, what do we do now?
Well, we start looking for the missing bits of other universes then, Andrew, of course.
Yeah. If you'd like to read that paper, it's in the monthly notices of the Royal Astronomical Society. So that's where you'll find the publication of that particular discovery.
There's a friendlier version on the conversation. Look for Twinkling Galaxies.
On the conversation website, yeah. That's it. I love that website. Really love it. Yeah. Yes, a bit easier to read as well. Yeah, this is the Space Nuts podcast. Andrew Dunkley here with Fred Watson. Let's take a short break now for a word from our sponsor, Namecheap.com. As their slogan says, search and buy domains from Namecheap at the lowest prices. This is the service the team at Bytes.com use to buy and manage our domains, and we're very happy with the service, support and value we receive. Can't recommend them highly enough. Buying the right domain name shouldn't be hard, and with Namecheap, we've found it to be anything but that. Find your dream domain and join over 2 million happy customers when you register with Namecheap. Trusted with over 10 million domains, you'll find you're in safe hands when it comes to turning your website idea into reality. They also have excellent tools to find the right name for you, like their handy search engine. Just type in your desired name, cross your fingers, and press search. If what you were after is already taken, they'll offer up some great alternatives. And if you're looking for some inspiration, try the new website domain name finder Beast Mode and discover thousands of domain names fast. We've found their prices to be excellent, management tools intuitive and easy to use, with excellent customer support should you need it. All in all, a great experience all round if you're looking to pick up a domain name or 2 or 3 or whatever it is you need. To check them out and help support us at the same time, just visit spacenutspodcast.com/Namecheap. That's spacenutspodcast.com/Namecheap. And Namecheap is one word. You'll be glad you did, and you'll find the URL details in our show notes and our website. Just visit the support page. Now, back to the show.
Space Nuts.
This is the Space Nuts podcast, episode 239. Andrew Dunkley here with Fred Watson. And I'd like to say thank you to the new patrons who have signed up. Thank you so much for joining us, and we really do appreciate your support of the Space Nuts podcast. And if you'd like to become a patron, it's really quite simple. Just go to our website, spacenutspodcast.com, and click on the Support Space Nuts button up in the top right-hand corner. Now, if you want to join through Patreon, you can do so for as little as $3 a month, but there are all sorts of packages available. You can also sign up for a year in advance for a discount rate, which may be an option for you. You can also sign up through Supercast, and we've got package deals in Supercast, so you can get 2 or 3 podcasts rolled into one for a small monthly fee. Of course, it's optional. It's absolutely optional, but our goal is to make Space Nuts an ad-free environment, completely supported by its listeners. And to do that, we need to increase the number of patrons. So if you would like to look into that, just go to our website, spacenutspodcast.com, and click on the Support Space Nuts link and go from there. Now, Fred, we have discovered yet another exoplanet, and this one is what's being described as a warm Neptune. So I'm assuming it's warmer than our Neptune for whatever reason, which I'm hoping you can explain.
Yeah.
Because I don't know.
Well, it's probably nearer to its parent star, which is called HD 183579, just to let you know. Okay, so this, in fact, is a really nice story, which is why I picked it. It comes from archival data, where you know, that's often the way discoveries are made. Telescopes are used to seek data from the universe. The astronomers who are doing that work, they write their papers on what they've found out, and then the data are archived. That's what happens at the Anglo-Australian Telescope where I used to work. It's what happens at the Parkes radio dish, and probably all the big telescopes of the world. And those archives eventually become public, usually only a couple of years or so after the observations have been made, and astronomers can trawl through them looking for stuff. And that's how this warm Neptune was discovered. In fact, it comes about because the transit method of determining whether there is a planet going around a star, and what you're looking for there is the slight dip in the intensity of the star as the planet passes in front of it. That's a transit. You can get what are called false positives, because you can actually find, for example, if you think about, and we talked about this situation a couple of weeks ago, where you've got several planets going around a star. How do you choose, how do you pick out whether this is one planet going round in a certain number of times, or 2 or 3 that are going round more slowly, and each one's crossing? And so these false positives are something you have to look for. And one way of dealing with it is to look at the Doppler wobble, which is the other method of finding planets. It's to look for the change in the speed of the star towards or away from us as the planet pulls it slightly backwards and forwards out of position. And so the gold standard is when you've got these two things together, you've got a transit and you've also got what's called the radial velocity measurements, the Doppler wobble measurements, and they line up to tell you that there is a star. And that's basically what's happened in this case. It's come from archival radial velocity surveys, actually, and they've basically found an object that was observed by TESS, NASA's TESS satellite, the Transiting Exoplanet Survey Satellite, and when you find when TESS spots the light dipping to reveal that there is a planet there, these things are given an allocation, which are TESS orbit objects of interest, and that's TOI. Now, I've got to fess up here, Andrew, that I think a couple of weeks ago, and it probably was on Space Nuts, but it might have been elsewhere, I said that TOI stood for target of interest, but it's not. And it refers specifically to the TESS satellite, and it is TESS object of interest. And this is number 1055b. And the B actually tells you it's a planet. So, really,
it was us. It was Space Nuts, because I think we talked about it last week.
Yeah. So apologies for that. Apologies to all Space Nuts listeners. It just tells you, as I've told you all many times before, I have no idea what I'm talking about. Why am I here? I don't know.
Well, Fred, nobody sent us a correction, which they're very quick to do sometimes. So you got them all duped.
Yeah, so they don't know what they're talking about either. That's the best bit of it. So what is it? And it does have another more formal name, because the star around which TOI 1055b orbits was already catalogued in the Henry Draper catalogue, which is why its number starts with HD. HD 183579 is the star. So it's 183579b is the name of the planet. Turns out to have around about a radius of 3.5 times that of the Earth, and about 20 times more massive. And this is the big difference between it and Neptune. What's Neptune's orbital period? I can't remember. It's getting on for 200 years. I can't remember the number. But this one goes around its host star once every 17.5 days. So that's the difference. Neptune is at a distance of about 30 times the Earth's distance from the Sun. This one is at 13% of the Earth's distance from its parent star. So that's why it's a warm Neptune. And it's warm rather than hot, because I think HD 183579 might be a red dwarf. I don't have a type for that star, but even though it's that close, its temperature is only in the region of 500 degrees Celsius. And
Neptune's orbit time is 165 years.
Okay, so yeah,
according to my very quick search.
Yeah, yep. So a very different sort of world, and it'd have to be, because in fact the idea of a warm Neptune really makes no sense, because Neptune's an ice world, because its atmosphere, some of its atmosphere is actually frozen down in the centre there as ice, and that's because it's so far away from the from the sun. This one is much closer to its parent star, so it's nice and warm, 500 or thereabouts degrees Celsius. I beg your pardon. I've now got. I've now looked further through my list of information, so I can tell you it is actually a sun-like star. It's got the same.
I just found the same thing at the same moment.
It's got the same spectral classification as the Sun. It's slightly more massive. It's a little bit smaller in diameter. It's a much younger star than the Sun, about half the Sun's age, and pretty normal, a pretty bog standard star, in fact. But what's really good is that this object it's 186 light years away from the solar system. It's actually very well placed for future observations, and that's really the main reason why it's in the news, because the James Webb Space Telescope is at the moment, or the scientists who will run it are amassing a list of interesting targets for exploring the atmosphere of these extra exoplanets, because that's where we're going to be looking for biomarkers in the atmosphere. And this is a target that is probably very high on the agenda. So putting the James Webb Space Telescope onto HD 183579 in a few years, when the planet is passing in front of it, gives you a really good chance of looking at the chemical composition of the planet's atmosphere. And that's where you start looking when you're looking for the spectrum signature of living organisms. So really exciting stuff that plays into all the important things that we're looking at these days.
And I can understand why they compare it to Neptune, because they're pretty much the same size, 3.5 times the diameter of Earth compared to 4 times, which is Neptune. So they're very close in terms of that. Similar planets orbiting similar stars. Interesting.
That's right, but in a much different geometry. Who'd have thought that you could have a Neptune that's only 13% of the Earth's orbital radius away from its parent star? It sort of almost doesn't make sense, does it? But it is, and that's the way planets work. It's this the universe, or the galaxy anyway, is full of this menagerie of different solar systems, and this is just a classic example. It's so different from what we used to.
Indeed. But, the more we look, the more mysterious it becomes in some respects, because we find these anomalies and they just don't make sense to us. But in time, maybe we'll solve some of these problems. You're listening to, or perhaps watching, the Space Nuts podcast with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
This is the Space Nuts podcast. Thanks for listening. Andrew Dunkley here with Fred Watson. And if you are a keen astronomy follower and you'd like to talk to other people with the same interest, you should join the Space Nuts podcast group or the Space Nuts Facebook group. There are two. The official Space Nuts Facebook group, which you can easily find, and we've got a big following there, and we appreciate that. But there's another page where the audience has created a group where you can all get together and talk to each other, ask questions, share ideas, share your photos. A lot of people do that. It's the Space Nuts podcast group on Facebook. But if you are not a Facebook follower, you'll find us on Instagram. You'll find us on, everywhere. Pinterest, Twitter, all sorts of places. So, yes, we have a pretty strong social media presence and a really good following. So, thank you for following us on those platforms. Now, Fred, we've got some questions, and they're audio questions, so we're going to use this high-tech method of getting them through to you, as always. And our first one comes from somebody named Ian. I found him, from Cambridge.
Hello, Andrew and Fred. It's Ian from Cambridge in the UK. Hope you're well. Just a question for you, or two, actually. The expansion of the universe has been described as a balloon being inflated. Because of that, how is it possible that galaxies can eventually collide if everything is moving away from itself? And secondly, living in Cambridge in the UK, I've actually never seen the Milky Way. I've looked many a times. I can't see it. I've even looked towards the south and I can't see the Milky Way. Is it feasibly possible to see the Milky Way from being so far north? Many thanks.
Thank you, Ian. Good questions. I guess we'll tackle them one at a time. And the expansion of the universe, if everything's moving out in all directions at the same time as at the same speed, well, the accelerating speed, as it turns out, how can things collide, such as the Milky Way and Andromeda in the not too, well, actually it is the distant future as far as we're concerned, but in the scheme of things, it's not that far away.
No, it's not. No, it'll be a good show when it comes. Ian, that's a great question. And it's all about the kind of scales that we're talking about, because, yes, the universe is expanding, but it's only when you start looking over significant distances that you can see the effect of that. And those distances are generally further than the distances between galaxies in groups. And we're in a group. We're part of something called the local group, which is about 20 galaxies, 3 bright ones. One is the Milky Way, one is the Andromeda Galaxy, and there is another one called the Triangulum Galaxy, which is a little bit smaller, and a little bit further away than Andromeda. Andromeda's 2.5 million light years away and is on a collision course, as Andrew has just said, with our own Milky Way. But those distances, 2.5 million light years, is local. It's actually very, very close by. And so the force of gravity between the Milky Way galaxy and the Andromeda galaxy is much greater than you would need to sort of compensate for the expansion of the universe. So the expansion of the universe is going on everywhere all the time. But on a local scale, gravity is by far the more dominant effect. And actually that local scale extends not just to a few million light years, but probably, to hundreds of millions of light years, because, for example, the nearest big galaxy cluster is the Virgo cluster. It's a huge cluster of 1,000 galaxies in the constellation of Virgo. It's about 50 million light years away, and we are being drawn towards that as well. But actually, it's quite interesting because we are being drawn towards it, but that's kind of on the limit because the universe's expansion is pulling us away from it, and it's a question of which is going to win. And in fact, I think eventually the expansion will probably win on that one. But that's the bottom line. It depends on distance. When you're looking billions of light years away, then the dominant effect is the expansion of the universe. And that's how we can measure their distances, because we know how fast the expansion is going. So a great question.
So it is. So it's gravity versus expansion. And in the terms of distance, gravity's winning in our area.
Yeah.
But ultimately the expansion will take over.
Yeah, that's right. In fact, it probably will never, the local group in which we are embedded, this local group of galaxies, will always remain intact probably. It'll splatter around a bit. But the other galaxies, the Virgo cluster, eventually the expansion will take it beyond a horizon that we can't see anymore, because it will need, the speed of light will be basically the expansion that's taking place. So it's we're now talking about 10, 20, 30 billion, probably more like 100 billion years in the future, that we won't see other galaxies except the ones in our own little system. A bit sad.
Yeah, how weird will the sky look when that happens?
Yeah, very weird, yeah. If there is.
And Ian's second question was about observing the Milky Way. I suppose for people like me who live in a region which doesn't have as much light pollution as some parts of the world, it's a bit easier. But I guess he's talking about his geographic location in terms of being able to observe it.
That's right. He is. Yes. Is it possible to see the Milky Way from being so far north? And the answer is yes. You can see the Milky Way pretty well from anywhere in the world, because it stretches all the way around the sky, and it's definitely brightest in the southern hemisphere, because that's where the centre of our galaxy is. And it's unfortunate because it means that the faintest part of the Milky Way is in the northern hemisphere, but it's still very, very visible. And in fact, Ian's question comes at a good time, because now February, March is the best time to look for the Milky Way in the northern hemisphere in the early evening, because it's basically right overhead. It's quite faint. So the thing that is killing it for you, Ian, is almost certainly the lights of Cambridge and surrounding areas. You need to get as far away from city lights as you can. Rural Suffolk's got some dark sites. I used to live in that area, at Newmarket, in fact, because I worked in Cambridge. This Cambridgeshire's got some quite dark places as well, but get as far away from city lights as you can on a clear, moonless night. It's no good looking if the moon's in the sky, because that will, or a bright moon anyway, that will tend to blot it out. But now's the time of year to look for it, because it goes right overhead.
So if it's overhead in the northern hemisphere, it's to our north in the southern hemisphere?
Well, we've got, because it goes all the way around the sky, we've got it overhead as well. Anyway. Yeah, and we can see it anyway. That's right.
Because it's kind of big.
It is big, yes. It's a magnificent thing, the Milky Way. When you see it clearly on a good night, and we've got this fantastic thing, the Aboriginal constellation of the Emu in the sky. To see that rising on May nights or thereabouts is just spectacular. You see the dark emu's head and its dark neck stretching down the brightness of the Milky Way to its body in the constellation of Scorpius. And you're just going to have to come to Australia when we can travel again and have a look from Siding Spring Observatory or somewhere like that to see what the Milky Way really looks like. But it is visible in the north.
Indeed it is. Thank you, Ian, for your question. Now we move on to a question that is sort of reflecting on something that happened in the 1960s that I'm sure a lot of people are aware of. Well, that's the focus of this question.
Hi, Fred. Hi, Andrew. This is Ronnie from Kentucky, United States. Long-time listener, first-time questioner. I have a question about the binary star system Zeta Reticuli. Research shows that in 1964, Betty and Bobby Hill claimed to have encountered extraterrestrial life forms from that star system and described the star system years before its discovery. I wondered how this is possible and if there is any logic behind this. Do we have very much knowledge on this star system? And with it being 39 light years away, is there any possibility of Earth sending probes or exploring this star system? Thanks for your time, and thanks for the best podcast I've heard. Bye.
Oh, thank you for the endorsement, and obviously you only listen to one.
No, I like the bit at the end.
Yeah. I like the question, and it sort of dredges up something from my childhood. They did make a movie about Betty and Barney Hill, and it terrified me, absolutely terrified me. And it's all about them being abducted by aliens, as Ronnie said. I wasn't aware of this this star system, the Zeta Reticuli or Reticuli. So what's the story with that?
Really interesting one. And in fact, if you go to Astronomy magazine, it calls it the Zeta Reticuli incident.
Right.
So it is. Look, the Zeta Reticuli is just a binary star system in the constellation, the Southern Hemisphere constellation of Reticulum, and it's about 39 light years away, exactly as Ronnie says. It's a double star. And you can see it as a double star with the naked eye. Actually, once again, it's two stars that are actually quite near, quite similar to the Sun in their makeup. And it's really curious that it's become the centre of all this mumbo jumbo, if I can put it that way. There is no known planet around Zeta Reticuli. There was a tentative discovery made in the infancy of exoplanet searches, but it actually wasn't a planet. It was a star that's pulsating. There's really nothing that makes it particularly special except for this really interesting, almost conspiracy-like theory in the world of alien, alien visits and things of that sort. I wasn't aware of the Betty and Bobby Hill issue, actually, back in 1964. But what I do know more about, because I occasionally use it in talks that I'm giving, is a story that's related to it, which will be familiar to many people because it's all over the web and it's really all over the alien conspiracy world, and that's Nibiru. I think you and I have talked about Nibiru, which is supposed to be a planet in our solar system. And that story goes back actually to Zeta Reticuli. It starts as Planet X back in 1995, when a lady in Wisconsin, her name is Nancy Lieder, Liedr, she says that as a girl she received an implant in her brain from extraterrestrials from Zeta Reticuli and has been talking to them ever since. And so she runs a website called Zeta Talk. And one of the I checked up on this a little while ago just to have a look and see, because I kind of pulled all this together a long time back. But the latest stop press news from Zeta Talk is that Australia is destined to tip over. And Western Australia is doomed because that's the way it's going, but we'll be okay in the east. So it's a bit of a shame about the square kilometre array. That's obviously had it. Let me just follow on from this, though, Andrew, because it wasn't Nancy Lieder who, I think, coined the idea of Nibiru. That goes back to some work by an interesting gentleman called Zecharia Sitchin. He's an Azerbaijani American author, and he wrote fairly prolifically about the possible existence of a planet with an orbital period of 3,600 years and intelligent inhabitants who may or may not like us. That's Nibiru. That's where the Nibiru story comes from. But it's got links with the Zeta Reticuli stuff. I sort of think, it's really interesting that, I should say, by the way, that Zecharia Sitchin passed away in 2010, so he's no longer with us. But what's really interesting about this is that I think in the world of astronomy and space science, we in some ways feed this kind of speculation because of the issue with Planet 9. The Planet 9 hypothesis hasn't helped this at all, because
and that's the first thing that popped into my head when we started talking about this.
Yeah. We say that there's behaviour, and we've talked about how that effect might have gone away. In fact, but some scientists think that the alignment of some of these very distant icy asteroids in the outer solar system, because their orbits are elongated and they're all aligned in a particular direction, it suggests that there's a massive object, actually something about the size of Neptune, a bit like the warm Neptune we were just talking about, very cold, because it's thousands of times further away from the sun than the Earth is, and it has not been found. We don't know whether that exists. I mean, the recent research seems to suggest that those alignments of the icy asteroids might just be a chance thing, that when you look at these icy asteroids in total, because we are only aware of a few of them, when you look at them in total, there might not be any alignment at all, so there's nothing to explain. But we do leave ourselves open for this kind of hypothesis. Nibiru, as I said, has gone viral. It's just totally unphysical. It doesn't make any sense. There was a lovely quote some years ago from our very good friend, whose name, that's ridiculous, whose name is escaping me at the moment, as it always does when these things come. That's ridiculous. That's so crazy that I can't remember the name. But I will quote from him anyway and remember his name in a minute. If anybody else asks me about Nibiru, the imaginary bullshit planet, I will slap them around their irrational heads with Newton's Principia. From Brian Cox, of course. That's Brian Cox saying what he thinks about Nibiru. Sorry, Brian. Yeah. When you get to my age, names are just usually on the third shelf up to the top left, and it's sometimes a bit hard to reach them. Good old Brian Cox, who, and in fact, I talked to Brian about this, and I think my answer was, well, we have a copy of Newton's Principia downstairs, so have a look at it.
I suppose. I mean, the word is hogwash. So that's probably where it stands in terms of the alien abduction conspiracy.
Yep.
As far as Barney and Betty Hill's concerned, it is Barney rather than Bobby.
Oh, is it? Yeah.
Their story is peculiar because this sort of happened in 1961, and it kind of happened very early in the alien conspiracy experience, if you like, the beginning of reporting of UFOs and the like. And some of the experiences that they detailed were incredible. And an average American couple coming up with such an unbelievable story is what makes this so fascinating. So, I do believe they experienced something, but I'm not willing to go as far as alien abduction.
Thank you.
Yeah.
I'm glad to hear it.
Something happened to them.
Yeah.
I don't doubt that. Something happened to them. But
you're stirring vague memories, actually, because I think I've looked at this stuff before. But I will have another look. Thanks to Ronnie for raising it again, because things like this are fascinating. And say a little bit more about human psychology, perhaps, than astrophysics. But I will check out Barney and Betty's story. And maybe we'll have a chat about it later on, Andrew.
And maybe dig up the movie, because it's terrifying film.
It terrified you?
Well, it was when I was a kid.
Yeah.
Yeah, I think the film came out in the 70s or something. I can't remember, but yeah.
No, go ahead.
Oh, no, I was just going to say thanks again to Ronnie for putting the question up, because it raises all sorts of interesting ideas and debate, and gives us the opportunity to say the words like hogwash and things like that.
Yeah. There is a lot of, there's a lot of misunderstanding around, and that's why you and I do this stuff, because we tend to tell things as they are, and as the best scientific knowledge that we have comes in, then we relay it to anybody who's willing to listen.
And before someone comes back at me, I'm not saying that intelligent life doesn't exist somewhere else in the universe. You can never say never. And I say that a lot. But, and I do believe life is prolific in the universe, but probably more at a microbial level. But never say never to intelligent life existing elsewhere. It's just such a massive, massive thing, the universe, and we can't see, most of it. So how can you say, no, there's no one else but us? But
that's the really annoying thing. We're never going to be able to say
it yet.
Yeah, we're never going to be able to say they don't exist. We're never going to be able to say that unless you look at every one of the 10 to the 23 star planets in the universe.
Exactly right. Yeah. All right. Thanks, Ronnie. And don't forget, if you've got questions for us, you can send them through on our website, spacenutspodcast.com. You can send them via email through the email interface, or as an audio question by clicking on the AMA tab and using, your voice. And don't forget to tell us who you are and where you're from, either way. And next week, we're going to dedicate the whole program, I think, to questions, because we've got quite a few now, and we need to bump a few off. And we've been getting a lot of questions, in particular from one individual who we now know a little bit more about. Quite an astute fellow, and he will be joining us on the program, and in a live situation, to ask us a few of his questions. So that should be interesting. And we're going to do it blind. We're not going to test it. We're just going to go in guns blazing and hope it works. But that's for next week. Fred, as always, thank you. It's been a lot of fun, and nice to put a few of these conspiracies to bed and learn a bit more about what's happening out there. Thanks very much.
A great pleasure, Andrew, as always, and I look forward to speaking next time.
Fred Watson, astronomer at large, part of the huge team of three that puts together the Space Nuts podcast. We're talking about our weight now. And from me, Andrew Dunkley, thank you again for joining us, and we'll catch you again next week. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.